Equality of temperature. Although temperature is a familiar property, defining it exactly is difficult. We are aware of temperature first of all as a sense of hotness or coldness when we touch an object. So, we are aware of temperature. First of all as a sense of hotness or coldness when we touch an object. We also learned early that when a hot body and a cold body are brought into contact, the hot body becomes cooler and the cold body becomes warmer. If these bodies remain in contact for some time, they usually appear to have the same hotness or coldness. However, we also realize that our sense of hotness or coldness is very unreliable. Sometimes very cold bodies may seem hot, and bodies of different materials that are at the same temperature appear to be at different temperature. Because of these difficulties in defining temperature, we define the equality of temperature. Consider two blocks of copper, one hot and other cold, each of which is in the contact with a mercury in a glass barometer. If these two blocks of copper are brought into thermal communication, we observe that the electrical resistance of the hot block decreases with time and that of the cold block increases with the time. After a period of time has elapsed, however, no further change in its resistance are observed. Similarly, when the blocks are first brought in a thermal communication, the length of the side of the hot block decreases and the time, but the length of the side of the cold block increases with the time. After a period of time, no further change in length of either block is presented. In addition, the mercury column of the thermometer is the hot block drops at first and that is the cold block rises. But after a period of time, no further change is height or observed. We may say, therefore, that two bodies have equality of temperature if, when they are in thermal communication, no change in any observable properties occurs. So with description, we can write the definition. Two bodies have equality temperature if when they are in thermal communication No change observable properties occur. For example, length, electrical conductivity, or other properties of a two substance.